I told some of you in class today that if you want to make money with calculus, use calculus to solve an optimization problem. If you can solve an optimization problem, you can figure out the best speed to drive your car at if you want to have the best gas mileage. If you could learn to optimize your earnings in the stock market, you could make the most money possible. So these are the kinds of things that help us make more money, save more money. That's one of the beauties of calculus. And we can do it even here with this one thing that we know so far, which is how to find a derivative. So in this problem, what speed should you drive your car to obtain the best gas mileage? That word best, that's our clue that we have an optimization problem. Anytime you see a superlative word, the best, the fastest, the longest, the shortest, the furthest, I've got a list there. That's how you know this is an optimization problem. We want to find the highest point on a graph or the lowest point on a graph. The highest point a function reaches or the lowest point a function reaches on some given domain. That's going to help us make a decision that's either going to save money or earn more money, something like that. So if this is our gas mileage function, the inputs are how fast we drive our car and the output is what the gas mileage is. We want to pick the best gas mileage. That's going to be the highest up gas mileage on the picture. So what are we going to do? Turns out calculus can help us find this. We said earlier that we could solve this graphically if we had some way to do it, or a calculator, which you do have a calculator that can help you do this. We could find the input value there, which is how fast we should drive our car to get the highest up gas mileage possible. Problems, we don't always know the original function. Sometimes we'll know the derivative of the function, but not the original function, and that's going to be the calculus we're going to be able to use to find an optimization. Remember, 4.1 was called extreme values of functions. We learned that there were absolute maximums, absolute minimums. There were also relative maximums and relative minimums. An optimization problem is just a real-world application of why you might want to find the absolute extremum of a function. So absolute maximum, maybe you want the highest profit, or absolute minimum, maybe you want lowest cost. But that's all this is. Yeah, there's going to be words in a context, but we really just need to find the absolute minimum or the absolute maximum of a function. And we learned in section 4.1 that that happens at an endpoint or at a critical point. It can be slightly more specific. An absolute extreme value can occur at an endpoint or at a local extreme value, and local extreme values exist. If they exist at critical points. But not every critical point is a relative extreme value. You will probably find that a couple days from now, I don't have a quiz or an assignment or something, and you have to find an absolute maximum, and you forget to check the endpoints. Don't forget to check the endpoints. I hope this is helpful. I've compiled this list of steps that you might use to answer an optimization problem. You probably don't want to memorize 7 steps, so let me give you the big picture. Imagine if we had a function and we wanted to optimize. Let's say we need the absolute maximum of a function. If I had enough time to sit down and list every single ordered pair on the function, I would just look down the y column and pick the highest one. That's optimizing. That would be the answer, is the y value I probably want to know about the x, but I'm just going to go down, I'm looking in the y column for the highest number, and I pick the x and the y from that row in the table. So that's not actually very hard, except I don't have a list of all the points of a function. So what we know about calculus already helps us really narrow down the list of points we have to check. So it turns out we don't have to check every single point on the function we want to optimize. We only have to check endpoints. There's a maximum of 2, right? And critical values. So there could be any number of critical values, but it's going to be finite, probably, most of the time. But we've just significantly narrowed this down. So instead of checking through this list, this impossible to make list of infinitely many possibilities, all I have to do is check through this list of endpoints and critical points, and I'm looking for the highest output value. Or if If I'm looking for a minimum, I'm looking for the lowest output value. So we're going to try these steps. I think you'll see that you kind of get the flow of them. Don't let the fact that there's 7 freak you out.